This question is saying, consider the equation. This is an integral and the value of the integral is 1. The range of possible values of a is given. Then you have to correct the true statement out of the 4 statements here. Okay. This is multiple choice, so more than one options can be correct. Okay. So we'll start by evaluating the integral here, this thing. So I can see that, okay, this is log x and this thing here. So what I'll try doing, this is log base is e, that is same as ln x, right? So this is ln x. I'll take, let's say ln x, I say as t, right? The equation here becomes, for ln x, I write t, so t to the power 1 by 2 upon, for x I can write, that means x is equal to e to the power t, right? So for this x here, I will write e to the power t, a minus t to the power 3 by 2 whole square. And for dx, you see, if x is this, dx is equal to e to the power t dt, right? So for dx, I'll write e to the power t dt. And the limit changes when the limit is of this. So x is 1 here. When x is 1, t is going to be 0, right? And when x is e, t is going to be 1. So the limit is from 0 to 1 once you have changed the variable from x to t. Okay. Now you see this is getting cancelled here. Okay. Next I can see that the differential of this one, t to the power 3 by 2, is 3 by 2 into t to the power 1 by 2. Okay. So it is safe to take a minus t to the power 3 by 2. This whole thing here. Let's say this is p now. Okay. I'm changing the variable once again now. Okay. So this transforms into, the limit will be, when t is 0, p will be a, right? When t is 1, p will be a minus 1 here. Okay. So the limit will be from a to a minus 1. And the integral becomes, this is t to the power 1 by 2 upon, here, if you differentiate both the sides with respect to t, what will happen? Minus 3 by 2 t to the power 3 by 2 minus 1, that is 1 by 2, is dp by dt. Okay. dp by dt is this. So dt you can replace by p dp upon this thing, right? So dt is dp upon this thing, minus 3 by 2 t to the power 1 by 2. Okay. And we had this was p here. So p square is there. Okay. Now you see t to the power 1 by 2 is getting cancelled, right? So this here becomes, limit is from a to a minus 1 dp upon p square, and that thing goes out. So minus 2 by 3 is a constant. It is going out. Okay. This is a minus 1. Okay. A minus 1 is the upper limit there. Fine. Now this is a simple integration, dp upon p square. You have to integrate. Integral of 1 upon p square is simply 1 minus p. Okay. So this thing now will become minus 2 by 3. Integral of 1 by p square is minus 1 by p, right? So minus 1 by p, and the limit is from a to a minus 1 here, right? Fine. Now from here I can write here, this becomes 2 by 3. I put the limit for p, that is 1 upon a minus 1 upon a here. Okay. So that is 2 by 3 a into a minus 1, and in the numerator there will be 1 here. Okay. So this is this much, 2 by 3 times 1 upon a minus 1. This is the value of the integral once I have evaluated the integral. This is given to be equal to 1. That means this is equal to 1. That gives me an equation in terms of a. Okay. This is a quadratic equation in terms of a. We can solve this. Okay. So from here, if I solve this quadratic, what I'm getting is 2 is equal to 3a square minus 3a. Okay, that is 3a square minus 3a minus 2 is equal to 0. Okay, so if I use the quadratic formula, a is equal to 3 plus minus root of minus 3 square, that is 9, minus b square minus 4ac, that will give you 9 plus 24, that is 33. Okay, upon 2 times 3, that is 6. Okay, so this becomes the value of a, right? 3 plus minus root 33 upon 6. So we have two values of a. Okay, now let's see the options given. So first is no a satisfies the above equation. That is wrong, certainly. Okay, this is wrong. An integer a satisfies the above equation. Is it really? No. Root 33 is an irrational number. Okay, so certainly this is also not correct. Okay, now an irrational number, option number C says an irrational number a satisfies the above equation. Yes, that is correct. This a value here we have got is an irrational number. Okay, so this is correct, certainly. Okay, more than, option number D says more than one a satisfies the above equation. Yes, certainly. We have two values of a, 3 plus root 33 by 6 and 3 minus root 33 by 6. So we have two values of a satisfying the above equation. So we have two values. So we have two options correct, C and D. Okay, so C and D becomes the correct option for this question. Okay, thank you.